Hello everyone, we're going to be going over section 2.7 today, which is about solving linear inequalities. So we're going to have 6 objectives. So first objective, we want to graph intervals on a number line. 2, we want to use the addition property of inequality. 3, we want to use the multiplication property of inequality. Number 4, we want to solve linear inequalities. 5, solve applied problems using inequalities. And 6, solve linear inequalities with 3 parts. So this whole section is just going to be about solving linear inequalities. So an inequality, as we've gone over before, relates algebraic expressions using the symbols less than, greater than, is less than or equal to, or is greater than or equal to. So with a linear inequality in one variable, here in this case in our green box here we have x, and it can be written in the form of ax plus b is less than c, ax plus b is less than or equal to c, ax plus b is greater than c, or ax plus b is greater than or equal to c, where a, b, and c represent real numbers or constants, and a does not equal 0. So some examples of linear inequalities would be like x plus 5 is less than 2, z minus 3/4 is greater than or equal to 5, and 2k plus 5 is less than or equal to 10. So we solve linear inequalities by finding all of its real numbered solutions. So for an example, with our set builder notation here, we have all numbers x, where x is less than or equal to 2. And this includes all real numbers that are less than or equal to 2. So really the numbers that we're thinking of is any number less than 2 or 2 itself. So we're thinking of numbers from negative infinity to negative 2. And a reminder that since we have these numbers of solutions anywhere in between negative infinity and negative 2, there isn't ever going to be one single solution. We're going to have intervals of solutions. So objective 1, we want to graph intervals on a number line. To graph the real numbers belonging to the set x, where x is less than or equal to 2, we place a square bracket at 2 on the number line and draw an arrow extending from the bracket to the left. So we're drawing our square bracket, and we want to draw our square bracket because our square bracket indicates to us that 2 is included. A round parenthesis would mean that 2 is not included, which gives you a strict inequality. Those are the inequalities that we think of when we say is less than or is greater than. So if you have is less than or is greater than, you'll have a rounded parentheses. And if you have is less than or equal to, or is greater than or equal to, you'll have a square bracket. So that is the main difference. So if we want to graph this solution on our number line here, we draw out a square bracket, and we're going to have it facing the direction in which our values are going to go. So we draw a square bracket at 2, and let's actually move this 2 over a little bit. So we're going to draw our square bracket here. And we see it's kind of facing the left, or it's open to the left, because our solution is all of these values and on. So this is how we would end up graphing the solution on a number line. We draw in our square bracket at 2, and we just fill in all the values to the left of our number line, or of the left of our 2 there, to signify to negative infinity. So the set of numbers less than or equal to 2 is an example of an interval on a number line. So you're going to write the interval in interval notation, which is as follows. We have a round parenthesis, negative infinity. Whenever you have positive or negative infinity, you always have to write the rounded brackets because infinity is not technically a value, so you can't technically say it's equal to. So whenever you have infinity, you have to give it a round parenthesis, but we include 2, so we give it a square bracket. And we write it in this form with our lower number, comma, higher number. The negative infinity symbol, negative infinity, does not indicate a number, but shows the interval includes all real numbers less than 2. So once again, it's not a real number. We're just indicating any possible number less than 2. So intervals in the positive direction are written with the positive infinity symbol, infinity. So we're just saying in this case that if we have positive infinity, we just write infinity with no sign in front of it. And that would indicate our numbers increasing, or numbers greater than 2 in that case. We draw a square bracket on 2 since 2 is included in our set, like we've said before. We would draw a parentheses if it were not included in the set. So because we had less than or equal to, it's that equal to that makes it a square bracket instead of a parentheses. So important concepts regarding interval notation. A parentheses indicates that an endpoint is not included in a solution set. A bracket indicates that an endpoint is included in the solution set. A parenthesis is always used next to an infinity symbol, whether that be negative infinity or positive infinity. And the set of all real numbers is written in interval notation as negative infinity to infinity. So now instead of writing the words all real numbers in curly braces, we can now just write negative infinity to infinity in parentheses to indicate all real numbers. Then we have some methods of expressing solution sets of linear inequalities. So we have our set builder notations here. And when we say that we have x where x is less than a, your interval notation is going to look like negative infinity to a, all in parentheses, and your graph is going to be filled in for values less than a, and you'll have a rounded parentheses at a. Then similarly for x less than or equal to a, it will be the same thing, but now instead you have a square bracket in your interval notation and your graph at a. Then if you have x where x is greater than a, you'll have a to positive infinity in rounded parentheses, indicating values greater than a. And on your graph, you'll have the values filled in for every value greater than a and a rounded parentheses. And similarly, just as before, we have x where x is greater than or equal to a. So we have our square bracket then instead of our parentheses around a in both interval notation and in our graph. If we say that x where x is a real number, so we're considering all real numbers in our solution, so from negative infinity to positive infinity, our number line will just be filled in the entire way, because we're saying that any real number can be a solution. So moving on to objective 2. We want to use the addition property of inequality. So just like how we previously used the addition property of equality, we can now also use the addition property of inequality, which essentially tells us that we can do the exact same thing as we did for the addition property of equality. Nothing's really changing except for the symbol. Instead of an equality sign, we now have an inequality sign. So we have if a, b, and c represent real numbers, then the inequalities a is less than b and a plus c is less than b plus c are equivalent, since you've seen that we've added c to both sides. In words, the same number may be added to each side of an inequality without changing your solution set. This also applies to anything similarly, like a is less than or equal to b, a is greater than b, or a is greater than or equal to b. So it works still for any kind of inequality we use. Similarly, just with the addition property of equality, the same number may be subtracted from each side of an inequality. So similarly to our addition property of equality, we can extend this to subtraction for our addition property of inequality. So we're just stating here that we can use the same property as we've been using before, just with our different signs or different inequality signs. Now, objective 3, use the multiplication property of inequality. While we can use the multiplication property of inequality very similarly to the multiplication property of equality, there is one key difference. If a and c represent real numbers where c is not equal to 0, if c is positive, then the inequalities a is less than b and a c is less than b times c are equivalent. So as long as the number that you're multiplying is positive, everything stays the same. Same as if you would with your multiplication property of equality. But if C is negative, or if you're multiplying a negative number to each side, if you have that A is less than B, then A times C is now going to be greater than B times C. And so we have that A times C is greater than B times C is now equivalent. So when we multiply by a negative number, we're going to see our sign is going to flip, or it has to flip. So you have to include that sign flip if you multiply by negative numbers. So in words, each side of an inequality may be multiplied by the same positive number without changing the direction of your inequality symbol. If the multiplier is negative, we must reverse the direction of the inequality symbol. And I'm going to highlight this for extra emphasis. If the multiplier is negative, we must reverse the direction of the inequality symbol. If you multiply by a negative number, you have to switch the symbol. You have to switch the direction. If it was greater than, it is now less than. If it was less than or equal to, it is now greater than or equal to. So if you have the equal to, that part stays. If you don't have the equal to, you wouldn't include it. So you're just flipping whatever sign was present. You're switching it in the other direction. So as with your multiplication property of equality, the same non-zero number may be divided into each side. So we're extending this property into division, again now for inequalities, but you also have to remember that when each side of an inequality is multiplied or divided by a positive number, the direction of the inequality symbol doesn't change. So as long as you're multiplying or dividing by a positive number, everything stays the same. But when each side of an inequality is multiplied or divided by a negative number, reverse the direction of the inequality symbol. So whether you're multiplying or dividing by a negative number, that symbol has to switch. So, all right. Objective 4.